Okay, 9.5a. Now in this lesson, we're going to start adding and subtracting rational expressions. So before we actually get to adding and subtracting those rational expressions, let's just review how we add and subtract fractions. Now, let's say we had 1 over 2, 1/2 plus 1/3. Now, anytime we add or subtract fractions, you need to have a common denominator. Now, what a lot of people like to do is just to multiply those denominators. Now, that does get us a common denominator. It doesn't always get us the least common denominator. In this case, it does work. Okay, so what we got to figure out is that least common multiple of 2 and 3, which is 6 in this case. So we need to get 1/2 to have a denominator of 6, and we need to have 1/3 to have a denominator of 6 as well. Okay, in order to do that, times 3, so 3 6, times 2 to get 2 6. So then we got 3 6 plus 2 6. Now that I have common denominators, just add the numerator and the denominator stays the same. Okay, now you get some cases where you actually only have to multiply one of the fractions. Okay, because our LCD, or least common denominator, of 4 and 8 will be 8. So in this case, I only need to find that common fraction for 1/4. Multiply top and bottom by 2, get 2/8, so then it's 2/8 plus 3/8, which will give us a total of 5/8. Okay, so again, that's an example of where I see a lot of people just say 4 times 8, 8 times 4, there I got my common denominator. If you were to do that, you will have to simplify in the end. Okay, so make it easier on yourself. Find the LCD instead of just a common multiple. Okay, so in this case, sometimes you're going to get 3, 2, 4, and 6. Okay, and we got to figure out that least common multiple for the LCD, which in this case will be 12. Okay, so 1/12 with a denominator of 12 will be, we're going to have to multiply top and bottom by 6. So 6/12. For 3/4, you got to multiply top and bottom by 3. So 9/12. And then finally for 5 6, you got to multiply top and bottom by 2. Okay, so then we'll end up with 10/12. And again, once you have that common denominator, you just add the numerators, which will get us 25, and the denominator stays the same. Okay, so we're going to apply those skills of knowing that we need to have that common denominator, and we're going to find that LCD into rational expressions. Okay, so for example, we're going to look here. Perform the indicated operation. We got 3 over 2x minus 7 over 2x. So whenever you see adding or subtracting, we're going to look for that common denominator. The nice thing about this one, we already have that common denominator. So in that case, all we have to do is actually subtract the numerator. So we're going to get -4 over 2x. Now, a lot of people like to stop there. We always have to check to see if we can simplify. Okay, 2x, that is in terms of multiplying. That's saying 2 times x. So now, since I have that -4 over 2, I need to check to see if that simplifies, which it does. Okay, which is -2. So that would simplify to -2 over 1x. So our answer in this case is -2 over x. Okay, here, again, I see addition. So I'm looking for that common denominator, x minus 4, x minus 4. They are common. Therefore, it's just a matter of adding the numerator, which will get us 3x plus 6, which I cannot combine, over that x minus 4. Now, again, whenever we simplify rational expressions, it needs to be in terms of multiplying. Okay, so therefore, the plus and minus, we don't need to worry about unless it factors, which this one does. 3 over x, 3 times x plus 2. So if we have an x plus 2 in bottom, we would be able to simplify, which we do not, because it is x minus 4. Therefore, we are done. Okay, but a big thing, always make sure if it factors, factor it to make sure that it does not simplify further. Okay, so those are a couple of the easy ones since we already had a common denominator. A little bit harder when they don't have common denominators. Now, the first one, we got 4 over 3x cubed plus x over 6x cubed plus 3x squared. Now, in 9.4, where we were just simplifying, we always factored. We have to have that same idea again. We always have to factor. Okay. Okay, so we need to factor that 6x cubed plus 3x squared. Okay, so GCF, 3 goes into both 6 and 3. Okay, and both terms have 2x's, so 3x squared times x, 2x plus 1. Now, this is probably one of the more difficult parts of all these adding and subtracting. We need to figure out that LCD. Now, what I do, okay, I always start with one of them. Okay, I typically start with the bigger denominator, one that has more terms. So I'm going to start with 3x squared times 2x plus 1. Okay, then from there, I'm done with that. Okay, that's going to be part of our LCD. Now, when I move on to the next denominator, I'm going to see what terms I already have. Okay, so when I look at 3, I already have that 3, so I do not need to repeat that. Now, when I move to the x cubed, okay, that's saying I have 3 x's. In our LCD at this point, I have 2 x's. So, and therefore, I need to add one more x. Okay, so if we add that x, that changes that to x cubed. Now, I've gone through all the terms in the denominator. That will be our LCD. Okay, now, so in order to get common denominators then, what I'm going to have to do is I'm going to multiply by, well, let's break this down. This first term, I'm going to multiply by whatever term I am missing. Okay, so when I look at that 3x cubed, so we'll go 4 over 3x cubed, whatever that denominator is missing, I'm going to multiply by whatever it is missing. It has the 3, I have the x cubed, I'm missing that 2x plus 1. So I'm going to multiply both top and bottom by whatever term I am missing. Okay, plus, because what I'm really doing, 2x plus 1 over 2x plus 1, that is just 1. So I'm not changing the actual value of the expression, I'm just getting it so I have that common denominator. Now, when I move to the next term, okay, so I got 3x squared times 2x plus 1. I got, let's see here. Oh. Okay, I have the 3. I have the 3. I have 2 x's. Okay, so therefore I need to multiply by x. And I have the 2x plus 1. Okay, so therefore, when I multiply that denominator, that's going to get me to have a common denominator, because then that's 3x cubed there. So what I got here now is 4 times 2x plus 1 over 3x cubed times 2x plus 1. Okay, which is our LCD. Okay, plus x times x will be x squared over 3x cubed times 2x plus 1. Okay, so now I have common denominators. Now I can actually add. Now, in order to add, we're going to have to distribute that 4 to get us 8x plus 4 plus that x squared over the LCD. Now at this point, again, we have that common denominator. We're actually just going to add. There's no common terms, or no like terms. So when I write this, x squared plus 8x plus 4 over that LCD. Now again, we always need to make sure that nothing factors. Okay, x squared plus 8x plus 4 will not factor. Okay, therefore, we are done. Okay, so always at the end, make sure you try to factor to make sure it doesn't simplify further. So let's just walk through this process real quick again. Okay, we started with this, and we noticed that we did not have a common denominator. Okay, therefore, we factored whatever we could in the denominator, so that one factored in 3x squared plus 2x plus times 2x plus 1. Okay, and again, when you're figuring out that LCD, start with one of the denominators. Okay, so we started with that 3x squared times 2x plus 1. Okay, so we got that covered. And then when we moved to the 3x cubed, I already had the 3. Okay, and then I had 2 of those 3 x's already in the LCD, so I had to add 1 more x to my LCD. That's why we got that 3x cubed. Okay, and we got the 2x plus 1 from the previous denominator. Then from there, okay, we go to each term, that 4 over 3x cubed. Okay, that denominator was missing the 2x plus 1. Okay, so we multiply both top and bottom by that 2x plus 1. And the second term, that denominator was missing one of the x's from the LCD, so we multiplied top and bottom by x. And it got us to that 4 times 2x plus 1 over that LCD plus x squared over our LCD. Okay, distributed the 4 so that we can add our numerators, and then we simplify. Okay. So on the next one, again, our first step is always to factor what we can. So the numerators, there's nothing to factor there. Our denominators, though, has to be x. Signs will be positive. And then to multiply and get 9, 3 times 3, 1 times 9. 3 times 3 looks like it works here. Okay, and then for this denominator, that's a difference of squares. That will factor into x plus 3, x minus 3. So again, at this point, once we have the denominators factored, we need to start finding our LCD. Again, pick one of them. I'm just going to go here. X plus 3 times x plus 3. Okay, then from there, move to the next denominator. When I look here, I already have one x plus 3. Okay, so I do not need another one. Now, when I go to the x minus 3, I don't have that in my LCD, so I need to add it to my LCD. Now that I think about it, let's go the other way. If we started with the other denominator. Okay, so let's start with that x plus 3, x minus 3. Okay, so now at this point, we started with that, and when I move to here, I have 1x plus 3. Okay, now when I go here, a lot of people think, oh, I already have the x plus 3, but what you need to remember, there's 2 of them. Okay, I only have 1, so I would need to add that second x plus 3. Now, if there was a third one, then you'd have to add another one. Okay, so in this case, our LCD is x plus 3 times x plus 3 times x minus 3. Now again, once you figure out the LCD, we got to figure out what is that denominator missing compared to the LCD. So in this case, we have the x plus 3, we have the x plus 3. I am missing the x minus 3. So I'm going to multiply both top and bottom by that x minus 3. Okay, so we're done with that term. We got our denominator to be the LCD. Okay, on the next one, x plus 3, x minus 3. Okay, that denominator now, we have the x plus 3, we have the x minus 3. I'm missing that second x plus 3, so I'm going to multiply both top and bottom again by that x plus 3. Now I have a common denominator. Okay, so we need to subtract now. Now, again, whenever we're doing that adding or subtracting step, you're going to have to multiply things out. Okay, so x plus 1 times x minus 3. We get as x squared minus 3x plus x minus 3 over that LCD. Now, do not worry about multiplying out the denominator, because in the last step, we're going to see if we can simplify, and it's going to be a lot easier if we're in factored form. Okay, minus, and that one's just going to be x plus 3 over the LCD. Okay, now I can actually do my subtracting. Okay, so remember, that whole thing minus the next one. Okay, the x plus 3. There's no other x squared, so that's just going to stay the same. Negative 3x plus x, that's going to be negative 2x. So then we got negative 2x minus x. Okay, so remember, follow through, minus x. So in that case, we're going to get minus 3x. And then we got negative 3 minus 3. Okay, negative 3 minus 3. We're going to get minus 6. over that x plus 3, x plus 3, x minus 3. And again, the denominator stays the same. Now, from there, let's double check that we cannot simplify. Okay, so we need to factor. Okay, in this case, x squared minus 3x minus 6 does not factor. Okay, so there is our answer. Now, another way you could write this answer, which is not necessary. Okay, we got 2x plus 3's, so you could say x plus 3, the quantity squared. Just another way to write that, not necessary. All right. So, adding again. So, first step, always to factor. I see a difference of squares here. X plus 3, x minus 3, and that second denominator is actually already factored. Okay, so let's figure out our LCD. Again, start with one of the denominators, and I'm going to start with the x plus 3, x minus 3. Okay, so we're good there. Now, when I go to that second denominator, x, I don't have just an x. Okay, so I need to add that to our LCD. Okay, this is not just x, that's x plus 3. Okay, so do not get that mistaken. Okay, x minus 3, I already have one of those, so I do not have to add it to the LCD. I've worked through all of our denominators, so there is our LCD. Okay, so when I go to this now, I'm just going to rewrite that term. And then what is that denominator missing compared to the LCD? It is missing that x, because I have the x plus 3, I have the x minus 3, so I need to add the x to both top and bottom. And again, it's multiplying. When I go to the second term, oh, we got the x minus 3. So now when I compare that to the LCD, that denominator has the x minus 3, it has the x, but it is missing the x plus 3. So I'm going to multiply both top and bottom to get that. So what I'm left with is x squared over the denominator plus 3x plus 9 over that LCD. Because again, I need to multiply that out to get that. Now I can actually do the addition, which will get x squared plus 3x plus 9 over our LCD. Okay, double checking. I have a square there, so I'm going to check to see if it factors. X squared plus 3x plus 9 does not factor. Okay, so then we don't have to worry about simplifying any further. So that is our answer. Okay, so that is 9.5a, adding and subtracting rational expression. Probably one of the harder things to do for this chapter. Okay, so again, let's just walk through the process real quick on this last one. Okay, we factored what we could. Okay, pick one of the denominators to start your LCD with. Okay, go to the next denominator, add anything that is missing, any terms that are missing to your LCD. Okay, then go to each term, whatever that denominator is missing compared to the LCD, multiply both top and bottom of that term by that missing factor. Okay, so do that for both terms or however many terms that you have. Now that you have that common denominator, okay, now you can actually add or subtract after you do that multiplying, like we did at the 3 times x plus 3. Okay, combine any like terms. Okay, at this point, when you get to your answer, make sure that does not factor. If it does factor, factor it to see if it does simplify any further. Okay, so your homework for 9.5a homework. Okay, add and subtract whatever it is asking for. Okay, now with those first 6, what you're going to notice, common denominators already. So therefore, just add or subtract your numerator, keep the denominator the same, simplify if possible. Okay, now the next 6 questions, all you are worrying about is finding that LCD, the least common denominator. Okay, so you do not have to do any adding or subtracting, but make sure to find the LCD there. That is probably that is the most important part when it comes to adding and subtracting these rational expressions. Okay, and then finally, those last 6 problems actually do adding and subtracting of those rational expressions. Okay? All right, if you have any questions, make sure you let me know. Otherwise, have a good day.